how do image textures actually work within Blender? There are so many tutorials that use image textures, but I feel like don't actually explain how they work. And honestly, it's bugged me how many times I go and watch a tutorial and so many aspects of the Blender development are just glossed over. Basically just giving you like these step-by-step instructions versus like helping you think, how do these things really work? Like when would I want to use this over this? So in our case today, that's going to be image textures. Image textures along with some other nodes in that shader editor. At the end of the day, the goal is to be confident when you're in Blender so that when you're creating your own creations, which I assume is the end goal for everybody, you actually have that right knowledge on what is the best tool to use for your specific situation. So today you're going to get to be a product designer where we're going to actually add a logo on top of a surface within Blender. Specifically, we're going to add our rabbit hole syndrome logo on top of our leather patch that we created from our last video on how geometry nodes actually work under the hood. To apply our logo to the surface, we're going to need to learn how colors and alpha channels actually work within images and image texture nodes and how you would connect those to other nodes. We're going to learn how transparency works inside that shader as well. Next, we're going to talk about UV maps and like what does UV even mean? Where do those letters come from? Why do we call it that? And what if you actually want to have multiple UV maps within your single object? Is that even possible? And then finally, we're going to quickly chat about bump maps, normal maps, and displacement maps. What do they really mean? When would you use one over the other? And then how can they be useful in our situation as we're adding our logo to our surface? Also, what if you want to combine multiple bump or normal maps? How do you do that? So this is what we're going to go over today. What I really want to do though at the end of the day is give you guys that true technical understanding of image textures and the shader editor so that you can be fully confident to know what to use when during your next creation. As always, I know I can't help but go down some rabbit holes along the way, but that's your fault for watching this channel. All right, let's get started. Okay, so first thing we're going to do here is bring in our leather patch. So we can go ahead and just delete our default cube. And we had already created this leather patch in my other video called I Wish I Knew This Before Using Geometry Nodes, where we dove into how geometry nodes work and we created that stitch. So of course, we're not going to do that all over again. We're just going to pull that in here. So in Blender, you can do what's called appending. You can go ahead and click append. And I already have my folder open for our geometry nodes tutorial. The cool thing about Blender is, well, first of all, it'll show you a preview of the blend file, but if you actually double click on that, you can actually drill into that blend file as if it's its own folder structure. So in this case, what I'm going to do is I'm going to jump into the collections, but you can really grab anything, right? You can grab a very specific material from that file if you wanted to. Instead, I'm going to go into the collections and I'm going to grab this patch collection. I put the patch into its own collection, so I'm going to go ahead and append that to our scene. There's our patch, and as you can see here, what it's done is it's actually added that collection to our scene. I think I prefer to just put it into the root collection, so let's go ahead and move that. And then often what I'll do here is this other collection I'll call studio, because I like to separate my actual subjects from my like camera and lighting. So now I can toggle them on and off individually, which can be convenient. So today we're going to spend most of our time in the shading workspace. So we can go ahead and go to the top here and click on shading. Perfect. And then we can expand this out a little bit. And as you can see, I already had my leather texture set up from before in the previous video. I kind of glossed over that in the last video just because that wasn't the focus. But what I'm actually doing is pulling in this material from, in this case, the Chocofur model manager. I'm not associated with Chocofur whatsoever at this time, so not sponsored or anything, but they did happen to have some free materials. So feel free to check them out. You know, they have some leather materials, which work perfectly for this situation, but you can grab fabric and marble and a bunch of other things for free. But again, like use whatever library you're most comfortable with and whichever one you like the best. In this case, I just used that because I wanted that leather texture. This Chocofur manager was an add-on, by the way, that they provided, so you can just quickly access them through here. And of course, when we click on our patch, which right now is called cylinder, so maybe let's give it a better name, patch. A circle curve is also not the best name anymore. This is called our stitch. And the first thing we see is all these nodes pre-set up for us. And this is perfect for this tutorial today because what I want to do is show you guys how to bring your logo, in this case, on top of an existing texture. So what I'm not going to do today is I'm not going to go over how this was created. In fact, I wasn't even the one who did do this. The intent today is to show you guys how to add your own images on top of something that already exists. I will go over just a super high level what's going on here though, right? We have our leather texture, which came from that Chocofur. So this is just an image texture. The color itself just goes right into our principal BSDF base color. pretty straightforward. They want a variable roughness on this guy. So what they've done here is they've taken the texture, they've actually inverted it. Otherwise you get something like that, which is kind of cool looking, but definitely not a leather texture anymore. They're performing this color ramp and then they're popping that into roughness. The color ramp is basically a way you can remap different colors within your image texture from one color or one shade to another. And I'm intentionally breezing over this because there's more important things to talk about in this video, but if you guys want to learn more about color ramps from my channel, just let me know. And then at the bottom here, we have our bump map, which I will be talking about later, but if you're not familiar with bump maps, just trust me for now. They're basically using this to add a little bit of real looking texture. Basically, bump maps allow you to describe the way that the light will bounce off of this surface, which we will talk about shortly. Okay, so the point again, we're going to be adding, in our case, the rabbit hole syndrome logo, which I have conveniently prepared for us in Figma. Figma is pretty awesome, by the way. It's one of my favorite vector UI design tools today. These tools are always changing, but today Figma, in my opinion, is one of the best. I mean, clearly Adobe loves Figma too, as they just bought Figma for 20 billion a couple weeks ago. So just a casual 20 bill, you know. So perhaps there's some other interest for Figma out there besides just me. And by the way, Figma is free for basically for individual use. So as long as you keep your files within the drafts, which are all stored in the cloud, by the way, which is convenient, you can have as many pages as you want. You can have as many projects as you want. Pretty awesome tool. Basically, if you're wondering how Figma makes money, their business model is basically targeting teams. So as soon as you work for an actual software development company or a design agency, marketing agency, you're definitely going to want to have multiple people collaborate on the same files. That's one of Figma's biggest value adds. And of course, that's when you start paying money, which it's well worth it at that point too, right? Anyways, I love that business model. I think it's really great. It gets a lot of people interested in the software because it is free until you need those next features. So I think they did a pretty good job of that. Anyways, let's get our logo prepared for our Blender file. So what I've done early on is I created my rabbit, which I know looks kind of funny when he's by himself. When he's cropped within the circle, it looks a little bit more normal. So I've already kind of prepared this, but I'm just going to do it again with you guys so that you understand what I've done. Basically in Figma, you have what's called components. In other vector UI software, you might call this symbols, where you can basically componentize things so that, for example, this is my component and this rabbit is actually my instance of that original rabbit. So I can go ahead and like change this guy, move the ear around, and anywhere else it uses that rabbit will just automatically update, which is really convenient. And then I've actually made the logo itself into a component so that I can actually create new instances of that. And then if I were to modify this, the other ones would update, which is cool. And this is one of the cool things about Figma is you can actually override colors in this case, or layers. So one way I might do this is I might come here and just turn the opacity of my background all the way down. And this is still linked, right? If I move this around, it's still there. It's just overriding that background color, which is awesome. But what I'm gonna do instead of that actually is I'm just gonna go ahead and come over to the left-hand side here into the layers, and I'm going to just straight up hide that background. I think this is just going to be a little bit cleaner. And then my eyes, I'm also going to hide them because I want my eyes to be transparent behind there. On the leather patch, we're basically mimicking the idea of burning this logo pattern into the leather patch. So we're either going to have burned in or not burned in. There's only two colors to deal with here, right? So naturally the eyes can't be white, they need to be transparent. And if you're wondering how I did that, in Figma you can have booleans, think just like booleans in Blender. So I'm actually subtracting the left and right eye from the head to boolean that out, and then I just have these additional eyes on top for the white. That's how that worked. And now you can see we just have this single color to work with. Again, love Figma for this, easily allowing you to change selection colors, but we're going to keep that to black. We're going to go ahead and create an export for this guy as a PNG. If you're not familiar, Blender works best with raster files. In fact, today you can't even use SVGs or any kind of vector file as its image texture, which at first I was disappointed about, but after understanding the technical logistics behind that, I think it makes a lot of sense actually. But let's focus on our job here. Right now our rabbit is 300 by 300. I think that's going to be a little bit too small for our patch. That's not giving us much resolution. So conveniently, instead of changing this, you can just go ahead and go 4x, and that will just export it at 4 times resolution. So in this case, it will make it 1200 by 1200. Of course, everything in Figma here is a vector, right? So it can easily expand that, no problem. I'm going to go export, and under my folder, I'm just going to create a new folder let's call it assets, and we'll just toss our logo into there. Perfect. So back to Blender. To add our logo to our patch, we're going to create a brand new node here called a image texture node. And if you're wondering where that is, by the way, you can go Shift A down to texture. We have our image texture nodes. From here, you can go ahead and open our image, and we're going to drill on into our assets folder that we just created, and then there is our logo, so we can open that. And then in the shader workspace, conveniently, we have our image editor right here, so we can actually just go ahead and click on the drop down and we can pull up that new logo that we just imported. And now here's where your trouble might start. Intuitively, to make this logo appear on the patch, what you might do is just go ahead and connect this color output from the image to the base color of our principled BSDF. Unfortunately, we just get a fully pure black color. We don't get our image at all. And you might be asking yourself, well, what the heck? Why is that happening? And this brings up the first point I wanted to chat with you guys about, and that is basically how image data is stored within an image and how that translates to these image textures. So if we head on over here to our image editor, one cool feature with Blender's image editor is you can right click anywhere, and you can see in the bottom left hand corner there, as I right click there, it actually tells me tells me a lot of things. It tells me the X and Y position of my cursor on this image, but also more importantly, in our case here, the RG and B value, as well as the alpha value. And I assume many of you already understand how colors are represented in Blender and just in general within a computer. But real quick, for those who don't know, every single pixel within an image has an RG and B value. And then in the case of PNGs, we also have that alpha channel. What does that mean? Well, basically, in order to generate any possible color, it's a combination of a red value, a green value, and a blue value, RGB. And then the alpha channel is talking about how transparent is that. So a 0 alpha, in our case, as you can see in the bottom there, would indicate a fully transparent pixel. Whereas if I right click on the rabbit himself, you can see now the alpha is 1. Right, if I come back here real quick, I'm going to disconnect this, click on my base color, pull up our color picker here, and if we head on over to the RGB tab, you can see, well, this actually wasn't defaulting to pure black, but if I pull that down, you can see RG and B, they're all 0. That would indicate the completely black value. If I pull my red all the way up to 1, then that has a pure red color. I'm going to pull my blue all the way up. What should that do? Blue and red together would make purple. And throughout the combination of these, you can basically generate every single possible color. Which, by the way, if you've ever seen this hex representation, the first two are indicating the red R, next two are the G, green, and the next two are the B. As you can see in my tooltip there, RRGGBB, and this is represented in hexadecimal as opposed to decimal. In Blender, though, it's not 0 through 255, which hex is indicating. It's actually just 0 through 1, which Blender then converts after gamma correction here to a standard hex value that you're used to dealing with. And what does gamma corrected mean? Well, if you can see here real quick, and I'll be quick about this. True to this channel's name, I'm always going down rabbit holes, but here we go. Say I have a blue value of 0.1, right? So 10% blue as opposed to the full 100% 1. So let's go 10% blue. In hex, let me just quickly pull up my calculator. So I have the programming calculator pulled up here. If you're familiar with Mac calculator, it usually just looks like this, but you can come up to view programmer. And the reason why I'm using programmer is to show you the different bases. So by default, in the real world, we all use base 10. You count 0 through 9, and then it repeats, right? As soon as you reach 9, now it turns into 2 digits. So now it's 1, 0, 10, 11, 12, all the way up to 20, all the way up to 100. So 99 and then 100. So this is called base 10. And turns out that's not the only base that exists. You can have base 2, which is what your computer knows, 1 or 0. You can have base 8, you can have base 16, and base 16 is what you would call hexadecimal. So instead of 0 through 9, you actually have 0 through 15, which represents a total of 16 numbers, right? So how do you represent anything above 9? Well, you represent it as letters, so A, B, C, D, E, F. So you go 0 through 9, and then A through F. And that's how you represent all 16 characters of base 16. So that's why if I type in 16 in base 10, if I go to base 16, that's actually 1, 0, as if it's 10, because this is exactly 16. Now let me quickly change this to 15. 15, we get F, right? As I said before, hexadecimal is 0 through 9, and then A through F. A being 10, B being 11, C being 12, etc. So from this view, I could just type in E, and then if I went back to base 10, what do you guys expect that to be? 14, right? A, B, C, D, E would be 14. So really in this back end, if you understand that logic, like we said, the first two are R, the second two are G, and then the third two are B. And each of these can be 0 through F. And then when you combine the two together, you basically get 0 through 255. And so then that allows us our red to be 0 through 255, green to be 0 through 255, and blue to be 0 through 255. Of course, in Blender, we don't use 255. We just use 0 through 1. So you would maybe expect that 0.1 would represent basically 10% of 255. So if we came back to our calculator, let's just go back to basic here. So if you had 255 times 0.1, you'd expect the resulting value to be around 25 or 26. And then if we go to programmer mode and do 25 or 26, let's do 26 in base 10, that should come out to like 1A in hexadecimal. However, when I come to hexadecimal, it's not 1A, it's actually 59. So what the heck? 59 in hex, let's do it. 59 in hex is equal to 89. And so that seems off. Why is our hexadecimal not translating to something that we would expect? And the reason why is because, as Blender is indicating here in brackets, this is gamma corrected. And what does gamma correction mean? Well, for most graphical editing on your computer, in particular for anything on the web, which many of us have dealt with before, everything is in sRGB space. So if we take a look at this visual here, this kind of gives us a good representation. So turns out linear space isn't actually completely even, at least not as we see on the screen. Turns out the distribution actually looks more like this in the real world, where most of that range is actually between about this point, and then after that it's just like a whole bunch of white, where our eye actually can't really differentiate any of these whites at all. But this is how the real world works for color, and Blender uses a linear space so that it can accurately represent color as we'd expect in the real world. However, when representing colors, this is a whole bunch of wasted space, so we actually basically take this distribution and do what's called gamma correcting to basically evenly split out each shade from black to white like this. So basically you're changing the distribution here. So if we actually had 0.1 in linear space, which is like somewhere down here, then after gamma correction, we're actually going to end up somewhere up here, right? Hence why we have that larger number. And there's actually tools out there that can actually do this conversion. I found this one tool called Color Math. You can find it on GitHub, where you can actually pass in our, well, so let's say we had, so that's R, G, and B. Let's go ahead and change this to linear sRGB space, and we'll change this to 0.1 like we had. So you can see after converting from linear to sRGB, we actually end up with 89, and that's a decimal, not hexadecimal. So 0.1 is not like 26 like we thought. After gamma correction is actually 89, which if we pull back up our handy calculator, we see that 89 translates to 59 in hex, which is 59 in hex. So I hope that made sense, guys. I was originally confused why our hexes were off, and after looking into the gamma correction stuff, that explains why. So back to the real purpose of this video. We're gonna try to throw this logo onto our patch. So we were talking about colors. If I right click over here in the image editor, it shows us the RGB and alpha values. So clicking here, we can see that we got 0, 0, 0, which means black, and then also 0 for alpha. And then for the rabbit itself, you can see we have RGB of also 0, which means black, which is no surprise. But we have the alpha as 1 because this guy has a full alpha. It's fully visible, not transparent. So bringing that back to here, we were wondering, how come passing the color into the base color, we just get fully black? Well, the reason why it's fully black is because it is fully black. The entire image is actually black. When you load an image in this image texture view, it's splitting the RGB from the alpha, right? So only the RG and B is coming out of this slot, and then the alpha channel is actually split into its own output, right? Technically, these are called sockets. So as we demonstrated before, sometimes it's the alpha is 1, sometimes the alpha is 0. And by the way, you can just hold down right click to do this. But as you can see across the entire image, in our case, for our rabbit logo, we are black across the whole board. So it should actually be no surprise that this color is black across the board. So that doesn't help us. How do we actually get our rabbit? Well, the thing that does change is our alpha channel. So what happens if we just take our alpha and pass that into our base color? Okay, kind of working-ish, but it's kind of mapping weird, and we're going to talk about that in a little bit here. That's called UV mapping. We're going to dive into all of that. What does UV even mean? But before we do that, we got to finish this thought. So I do want a better visual here. So what I'm going to do real quick is I'm going to add a texture coordinate node. And then for now, I'm just going to pass the generator into the vector. And I'll explain what generated means in a second. So there's our logo, although it's inverted. Why is it inverted? Well, if you recall, colors in Blender are 0 through 1, right? And if I just pass a single value into here, it will basically override the RGB altogether to be that color. So I'll just show that real quick. If I just put a dumb old value here, pass it into my base color, 0 would change RGB all to 0, which is black, and then 1 as I go up higher would change it all to white. RGB of 1 represents white, right? And then anything in between would be a gray. So if I pass my alpha channel in, well, what's our alpha going to be? When our alpha is not on the rabbit, our alpha is 0, and when it is on the rabbit, it's 1. But if we just take that and translate it to our color, then that would actually mean 0 would be black for the background, and alpha of 1 would be white. And so that's why we're actually getting this black and white, which is not quite what we're looking for. One thing you could do here is, we have a node in here called an invert node. So you could put that in here, toss that in between, and we do have much closer to our final product. But this really isn't the right solution here, because at the end of the day, we want to add our logo on top of our leather texture. So doing this doesn't really give us enough flexibility. So what's the better way? Well, we can take away this inversion and add a different node here called a MixRGB. And why are we using MixRGB? Well, okay, first of all, what even is MixRGB? Well, essentially what you're doing is you have two different colors. You can set them to be whatever you want, or you can pass something into it, which we'll do shortly, and you give it the factor. So factor all the way at 0 means use the first color, factor all the way at 1 means use the second color. Anything in between will, as you might guess by the name, mix them together. And if you're familiar with any kind of blending modes, they have all the most common blending modes available, including darken, multiply, lighten, screen. If you've done any kind of graphical design, I'm sure you have seen these before. But we're just gonna keep this to mix for now. So why is this useful? Well, we could, if we wanted to, pass our alpha channel just into here. However, that's not super useful, right? Because either we get our full thing or we blend into white, and that's it. So white being our background color, let's just make it like whatever, anything else, blue for now. We can kind of fake it, but if we go halfway through here, we're actually only getting a transparent rabbit. It's not fully white anymore. What if we wanted it to be? And we're not getting that full background blue either. So this isn't the best approach. But if you think about this for a second, what if we actually passed our alpha into the factor itself? You have to remember that in Blender, a color, or in this case, the factor, doesn't always have to be just one value. Like right now we're saying make it let's say 0.5, and it will apply that 0.5 across the entire image, right? But just like color, down here, we have a solid blue color here, but as soon as I pass something like my alpha channel from the logo into it, the color actually changes as you go across. So literally under the hood, Blender is going through every single pixel here, and then at a certain point, it sees, oh, in my image, the alpha is 1, so then it decides to now change the color for that pixel to white, right? So these colors will actually change per pixel, and that's a key component to understand. And so this also applies to something like a factor. So if you think about it, if we pass our alpha into the factor, what it's doing is it's still going across each pixel one at a time, but instead of changing the color to whatever the alpha is, it's actually changing the factor to whatever the alpha is, right? So if we get to a certain point, let me just hook this back up. When we get to a certain pixel on that image, it will actually say, okay, the alpha was 1 on that pixel, and now I'm going to make the factor 1, which in this case will use the bottom color, it's fully 1. Or if alpha was 0, it will use the first color 1. This is perfect because now we have that full flexibility. So really we want our color 2 to be black, and then our color 1 will be whatever our background color is going to be, right? And now we can pass anything we want into this color 1, and that will represent our background. And then in this case, we can actually change our foreground rabbit color to whatever we want. What I'm going to say though is let's go ahead and pass our color from our logo into this color, which in this specific case will just be black because that's our logo. But what if you had an image that had many different colors in it? Well, if you didn't do this, you would be forced to just stick to one solid color across your entire foreground. But if you pass this in, this is just better practice because in our case, it didn't matter either way. And maybe you actually want to change the rabbit's color without having to export a brand new image. In that case, yeah, don't hook it up and change it there. But in general, you're probably going to want to hook up that color. So now we got alpha to our factor, we got color to our end color here, and now we have color 1 as our background, which is perfect because now we can go ahead and take our original leather texture, which if you recall was just hooked up like that. Now we can simply add that to our color 1, connect this guy back up, and we have that exact texture, literally exact right now, right? We can be 100% confident that anywhere where there isn't a rabbit right now, this brown texture was exactly like it used to be when that was connected up like that. And we can also be confident that the black color of the rabbit is exactly what was coming in through our original logo PNG file. So this is looking pretty good. Now, let's work our way back over here and talk about what I skipped earlier, which is this texture coordinate. What is texture coordinate and how does it actually work? What's with all these different options? What do they really mean? Why did I connect generated? What does that do? Funny enough, actually, if you look at the bottom, we actually have that projected on both sides, which is, in my case, not what I want. Probably most of the time, not what you want. So here we go. So texture coordinate is actually an input. If I do Shift A input, we have our texture coordinate option. And what is an input? Well, an input basically will output something very specific based on what you're putting it into. And what does that actually mean? Well, in this case, we have our logo PNG and we have our final patch object that this thing is actually applying the texture to, right? So what texture coordinate does is it allows us to adjust how this image is getting mapped onto that object. And many of you probably know this already, but I think it's important to talk about it a little bit, like what's actually happening here, right? How does this texture coordinate really work? Because most tutorials that I watch, this is just like tossed in within a half a second and then they move on. And it's always kind of bugged me that this is glossed over, right? So in this case, generated, what does generated mean? Well, generated actually will think of it as basically doing its best guess to try to map your image onto the object. You can kind of think it like that. What it really does is it maps it in the Z direction. So conveniently our patch is facing directly upwards, but if I had rotated that, you can see that it's still trying to map it on the Z direction, right? You can almost like think of it as like almost like pretend there's a projector right above it projecting an image down in the Z direction. It's kind of what's going on here. And in our case, that isn't actually what we want at the end of the day, but that's an option. Then there's a bunch of other ones like normals and UV maps, which we'll talk about shortly. Object, camera, window, what do these mean? Well, let's put like camera in here and see what happens. As you can see, this is actually dynamically mapping this image according to my current camera position. So you can see I'm actually rotating my viewport, in this case, what's considered the camera, and it's actually dynamically also rotating and projecting basically this logo with it, which is kind of cool. There's certain situations where you might actually have a benefit for this. In our case, this is not what we want. Window is kind of similar. So you can see it's actually based on our current window projecting that image, which is interesting. And there's some other ones. I'm not going to go through each and every single one of these, but you get the gist. Each of these in their own way defines how this image is going to get mapped to the surface. But the one that we actually really care about today is UV. And likely you've heard of UV before, UV mapping. We're back to our original look. And by the way, we're back to the original look because if I disconnect this texture coordinate from our vector, as you can see, it's the exact same one. What does that mean? Well, it means that the default texture coordinate for an image texture is the UV, right? So, I mean, at the end of the day, this image texture needs to be mapped somehow. So it's not like you can just pass it nothing. So even though like nothing's passing here, it needs a default. The default is in fact a UV. Okay, what is a UV? UV mapping essentially allows you to fully customize how your image is going to get mapped onto a surface, which I'd say in 99% of scenarios is what you would want. In this case, it did its best guess and it failed. This happens to be the default UV mapping for this object, so we're going to adjust that. And to see our UV mapping, actually, what I'm going to show you is right now we're in our image editor. When I first started with Blender, this confused me. I was always confused why I couldn't see my UV mapping. Make sure you're in the right editor. We need to go down to the UV editor, which in fact will still show your image like it did before, but this editor is catered for UV mapping. And if I tab into my object, so you're always going to need to do this when you're UV mapping. Right now we're in object mode, so I'm going to click tab to go into edit mode. And when I highlight my object, which is important by the way, I was always confused, where is my UV mapping? Hit A on your keyboard, that selects everything. And what you can actually see is going on here is each of these faces and vertices are getting actually mapped to this view here, which is what we call UV mapping. Now, if you're like me, you might be wondering why UV? What does UV mean? Like, I've only ever heard UV before as what, like ultraviolet? Okay, nothing to do with ultraviolet. Why is this called UV mapping? What does UV stand for? Well, at the end of the day, it's more or less arbitrary, but the letters U and V actually come from a coordinate system, right? So in our Blender viewport, we have basically an X, Y, and Z, right? X represents our X axis, Y represents our Y axis, and Z represents our Z axis. But when it comes to mapping an image on a surface, we're kind of stuck to 2 dimensions. And so we don't want to call it XY mapping, to represent those 2 dimensions because that's confusing. That's we're already using XY for this 3D viewport. So we need to come up with new letters to represent our 2D mapping of our images onto surfaces, right? So X, Y, Z. Okay, well, what letters come before that? Turns out U, V, W are the ones that come before that. And in some systems, not Blender, but in other 3D systems, you can actually have a W, a U, V, W, where W represents that last dimension of texture mapping. In Blender, it's just 2D, so we just call it UV mapping. But that's where UV comes from, right? You can think of UV as X and Y, but we're intentionally choosing different letters so that we're not getting confused with X, Y, and Z. So let's go back into our edit mode. We have our UV editor, and as I said before, if we hit A to select our surfaces, we actually see them all here. Now, we actually kind of lucked out here because each of these is a very clean UV mapping. As you can see, one of these circles must represent the top face, the other circle must represent the bottom face, and all these lines represent each of these faces on the edge, right? In our case, really the only face we care about is the top one because that's where we want to map our image. But in your case or in many other cases, you actually do need to care about sometimes all the different faces, right? So there's multiple ways to do this. If I select all here, then all my UV maps show up here. Now it's kind of inconvenient because you can only click on a vertex at a time, or I could select the whole face. So that might be nice. And I did that by just switching up here to face mode. Islands are super nice in UV mapping, so click on that one. This is actually probably the most useful one because now you can just click on islands as a whole to select them, and then just like anywhere else in Blender, if I hit G, I can move these around. You can hit S to scale them, right? And you can actually hit R to rotate them as well. So just for completeness too, I'll just show you, say I was in vertex mode and I was clicking on these, you can actually hit L, which basically says select a link. So that could be another way where you could easily select all the linked ones. This isn't just for UV editor. If you've done any kind of modeling whatsoever, I can hit L there and it will select all the linked ones. So if I had multiple objects, picking this vertex, hitting L will only select that one, and then here and hitting L here will only select that one. So super convenient. But back to UV editing, I'm gonna go select islands. Another thing you can do here too is if I go to face mode, since I really only care about this top face, I can just click that and only that one's going to show up. So as we can see, it was actually the left hand one that represented our top face. I come down here and click on the bottom, you can see that's the bottom. And it's of course where we position this UV map on our image that tells Blender how to map that image onto our surface. So if we want our rabbit to be kind of inside this patch, then what we can do is we just need to hit S to scale this UV map and actually pull it up until it's about where we want it. One note real quick, if I go really big here, you can see it's actually repeating, which I don't want. The reason why it's repeating is because in our image texture options, we had set repeat on. What I'm gonna do instead is hit clip. Another option is extend, which I believe if my logo went all the way to the edge, it would just extend that on. In my case, I think for this exact situation of adding your logo, probably the most useful option is clip, which basically says at the end of my image, clip it, no more repeating, that's it. So I'm gonna scale this guy back down. By the way, I'm hitting A on my keyboard to select everything. I could have this rabbit go to the very edge of the patch or even the edge of the stitches, but I'm just gonna come in just a little bit here. I think in the real world, when you're etching out a leather patch, you need to give it a little bit of clearance for that stitch, so I'm gonna do that. Also in the real world, I think the stitch would probably be a little bit further in, so I'm just gonna pull that in a little bit. Thankfully, we created this super handy stitch pattern using geometry nodes, so it automatically adjusts for us. If you're wondering how I did that, feel free to check out my other video called I Wish I Knew This Before Using Geometry Nodes. And if you're wondering, hey, where did my UV map go? You always need to be in edit mode. Remember, I just switched to object mode, so let's tab back in. That might be one thing that will frustrate you. So I'm gonna actually make that a little bit smaller there. You can have full control here, so maybe I'll just bring that just into the corner a little bit. By the way, if your logo wasn't rotated in the correct orientation that you were expecting, of course, it's as simple as just hitting R in our UV mapping and just rotate this guy. And as you can see, that will rotate them on the surface. But I think we actually had it pretty good to start. Now, one problem we haven't addressed yet is if you look at the bottom, we still have that other face mapping on. And that's just because we never moved this other map anywhere else. So what we can do is just hit G and just take it off the screen. Honestly, that's all you need to do. Take it off the image rather. Same with this guy here. We'll just go ahead and G and Y right up there so that none of these guys are overlapping the image. Technically, I could put that right there and it would be fine, but I just want to move it away. Got to keep yourself somewhat organized, right? Okay, so perfect. We have our image mapping. Now, I just want to touch on one point real quick that I glossed over, and I glossed over it because I just happen to have a really nice UV map. But if you have a more complex object, the default map mapping may not be what you expect, or it may not have a default mapping. So one thing you can do in here is in edit mode, there's this UV menu here, and this gives you different options to do what's called UV unwrapping. You can also hit U on your keyboard to pull up that same menu. So to have full control here, you can actually create what's called seams. So like ours is so simple that we didn't need to do this, but typically to do this, you'd have seams. It's basically telling Blender, how should I divide up the faces and vertices of my object to create those UVs. So for example, I could select just this top edge, and to do that, I can just hit Option or Alt on my keyboard, and my screencasting isn't showing up again, is it? Sorry about that, guys. So if I click this and then go ahead and hit, in my case, Option or Alt on Windows and go around, that will select our top face. And what I could do is I could hit U and then say Mark Seam, and then you can see that's actually turned red, and that's telling Blender this is one of my seams. I'll do the same thing on this bottom surface, mark that as a seam. It's not a right click, it's a U, mark seam. If you got it wrong, by the way, you can go clear seam and reset. And then finally we can select everything and go unwrap, and that will actually pull it onto here. Now, I don't like how this unwrapped. We had it way better the first time, but I'm just trying to demonstrate something you might do. Another option is instead of those seams, which I'll just clear real quick, you can try what's called Smart UV Project, where as the tooltip says, it'll try to be smart on the way that it unwraps it. So basically you can set a certain angle on which it should basically split those faces, and you get a couple different options here. Feel free to play around with them. And when you say okay, now this one's a little bit cleaner, right? It looks almost like our original one, although I guess it decided to split our edges into 4 separate ones. So again, I'm just going to undo that so that we can go back to what we had before. But most likely when you guys are UV unwrapping, you're going to need to know about these different options. Now at this point, you might be wondering, especially if you've done lots of UV mapping like this already in the past, you might be wondering, well, at the end of the day, I just have this one object, this one material, but I have actually multiple different images. In this case, we have one image that's a texture, our leather texture, and one that's like our logo. And what if I wanted to actually have a separate UV map for my leather texture from my logo? That's tricky, right? Because at the end of the day, it's just one object. I'll show you what I'm talking about. If I pull up my leather texture here and I tab back into this and hit A, here's our, it's sharing the exact same UV map, right? So if I come here and I could scale this up and down, you can see, hopefully you guys can see there, like the logo and the actual leather is scaling together, which, I mean, in my opinion, is actually not what we want, right? In an ideal world, we can scale our logo and our actual leather texture individually. So, one solution you might be thinking is, oh, okay, that's all right. What I'll do is I'll just go ahead and add you might have seen what's called a mapping node to here. We'd also need to add a texture coordinate as well. And right now is when I'm going to talk about the Node Wrangler add-on. There's a good chance you guys might have heard about this add-on before. Basically, in our add-ons, we have Node Wrangler. It's built right into Blender, just not enabled by default. And as the name of the add-on suggests, it allows you to wrangle the nodes. And by that, I mean just gives you a bunch of convenient shortcuts if you're working with nodes a lot. One of those shortcuts you might have seen people use is the Control-T shortcut. And all that Control-T shortcut does is just automatically add this mapping and texture coordinate node. I was manually doing that just a second ago. Nothing stops you from doing that, right? But it's a little bit more work. So by the 100th time, maybe it's time to just enable the add-on, and then you can hit Control-T. And we'll actually do the same thing here just for consistency. And like we talked about before, the default texture coordinate is the UV map. So if I take that off, this is using the UV map by default. So I'll get that back up. And back to our problem of separating the texture, the leather texture from the logo. You might be thinking, well, now that I have this mapping, I can individually adjust this. So I can adjust my scale of my leather texture here, and then I can adjust the scale of my logo here. And I mean, you're right, you're not wrong. This will totally work. And if you can manage to get the look you want using this strategy, then go for it. But I actually want to show you guys another approach, and maybe a technically more correct approach here, especially if you want to still use UV maps, right? So coming back here, and by the way, another reason why I liked using the UV maps here over the scales is because I can position this exactly how I want and scale it from the center. Whereas my logo here, if I were to scale from here, you can see it's actually scaling from the bottom left-hand corner, which makes it super annoying because now I have to try to move this position around if I still want that centered, etc. So I'm just going to reset that. Technically, and I've seen this done before and I've tried it, you can actually create fancy math operations to make the scale actually scale from the center. It's quite a bit of work for what it's worth, but if you really needed to, then you can. Perhaps you need to do that for some very specific procedural reason. But in our case, we're going to stick to UVs. So let's come back to here. And here's where I want to mention the feature of multiple UV maps. I actually didn't know this was a thing, and I'm not saying everyone thinks like me, but perhaps some of you guys didn't know this existed. If we come on over to our mesh or our object data properties tab here on the right hand side with our patch selected, you may have noticed a drop down for UV maps. And as you can see, we do have a UV map here because we've already mapped that. This was created by default for us. But here's the cool thing. Nothing stops us from creating multiple UV maps. So we just spent a bunch of time getting this logo perfect. So I'm going to call this default one our logo UV map. But what if we want to have a separate UV map for our leather texture? So I can create a new one. I'm going to name it leather, as I highly recommend you do with everything you do in Blender. Please give it a name. And now we actually have two separate UV maps. And how would I go about modifying my second UV map? If I select that here and start editing this, I can actually start changing my second UV map. However, that doesn't seem to be doing anything, right? Why does that not seem to do anything? Neither my logo or my leather texture is changing. Well, we haven't done anything to tell it to do that, right? By default, you can see there's this active icon here, which means this is our active UV map. And what active means is when you connect the UV map from this texture coordinate to, if we pipe that through to our texture, or of course, if we just disconnect this altogether, it'll default to that active UV map. You can only have one active UV map. So if I go ahead and change the active one to now my leather one, and then I go ahead and change this, you can see now that one's changing instead. However, we haven't solved our problem yet because we still are only scaling the logo and the leather texture together. How do we do it separately? Well, turns out there's actually a node in here specific to UV mapping, right? In this case, we don't have an option to choose the UV map, right? It's just always going to use the active one. So if we go and search for UV map, we look at that, we actually have a dedicated node for UV mapping, this time with the option of choosing which UV map we want, which is perfect. So we actually don't even need the texture coordinate anymore. As you can see, what I did is I selected the logo UV map, which is talking about this guy, and passing that guy in, and then I'm just going to Shift-D duplicate that guy, do the same thing down here, get rid of that texture coordinate node, but this time we're going to change it to leather. And now with the logo selected, I can go ahead and adjust the logo's UV map. I hope that's clear. You can see the leather texture in the background is not changing. Now, if I select the leather one, I can actually adjust that one on its own as well, which is perfect. Now, I was actually pretty happy with the current size of that one, so not sure if there's really that much we need to change here, but most likely in whatever application you're doing, this could be very handy to do. And like I said, I feel like this is technically a little bit more of the correct approach. This certainly was a little bit more work, but in my opinion, that doesn't really matter. Really, we want to have the greatest amount of flexibility here, right? And if we can understand all of the possible options available to us, that gives us the most freedom, right? Cool, so I think we've covered UV mapping. By the way, one thing I didn't mention before is, what if you actually want your logo to be literally transparent on top of a surface? Maybe you're trying to, apply your logo as a sticker on a piece of glass or something. How would you do that? Well, in the case of a principled BSDF shader, there is at the bottom here, you can see is this alpha option, which will change the alpha. But wait, hold on. I just changed the alpha to be half visible, but nothing seemed to change. What's going on here? Well, the reason for that is because right now we're using the Eevee renderer, and most likely you're familiar with the different render engines. We have Eevee, we have Cycles, and even if we change this to Cycles, we still don't see any transparency. Why is that? Well, it's because we're actually on the viewport shading tab, which is, this tab is this exists basically to help you shade your stuff. It gives you basically this default HDRI image that's, the whole intent is to kind of give you a potential environment with a whole bunch of different colors and variations to help you visualize your textures and your shading with as much dynamic content as possible. Of course, if you're not familiar with this, you can just come into this drop down here and you can actually go ahead and change your environment. Just keep in mind, this isn't going to get rendered, right? These environments that you choose is just kind of to help you out as you're shading your objects, right? The point I want to make is this material preview mode, as opposed to the actual render mode, which is over here, This view is actually using Eevee under the hood. So even if you've changed your render engine to cycles, and over here now you can see this is truly using cycles. If I come back to the viewport shading, this is actually using Eevee under the hood. So if I switch our render engine back to Eevee, just because I want to show you how to do the transparency in Eevee, which by the way, the whole point of Eevee was created to basically allow you to create your renders way quicker than you would in cycles with trade-offs. Right? In the same way a typical game engine will work, where if you're playing a video game that's 3D, it can't use a render engine like cycles, right? Because it would just look awful. It's just no computer's fast enough to render in real time with cycles, at least not most consumer computers, right? So all the game engines out there will actually make sacrifices. It's not going to look quite as good, but they give you a whole bunch of different options to allow, in the case of games, the developers to pick and choose which features they want the most and trade that off with performance, right? And basically Eevee does exactly that. It brings that same game engine concept to Blender so that you can actually tweak exactly what you want, sacrificing performance or not. So the reason why I'm mentioning all this is because by default, Eevee turns a whole bunch of things off, right? By default. Well, for example, I'm in the Eevee right now, like ambient occlusion. You can see already like the shadow from the stitch. That wasn't visible until I chose that bloom, screen space reflections, all this stuff, right? But in addition to these, if we come on over to our material tab down here, if we scroll down to our settings here, there's actually some options that's set by default. And one of those options is this option called blend mode. And as you can see, the default that Eevee is set, this blend mode on our patch is opaque, which means it doesn't support any kind of transparency. And why did it choose this as a default? Well, it's quicker, right? It's quicker for Eevee to render an opaque object over something that has an alpha transparency. But if we change that to alpha blend, now you can see we're actually truly getting that alpha that we would have expected when we set this value. Now, why are we getting this weird artifact in here? It looks like the logo and the textures are struggling. This is actually something that can be solved with a setting here called backface culling. Basically, when you set Eevee to alpha blend mode, it struggles to know which side of the face to show. So it kind of shows them all depending on the current view that you have. So enabling backface culling will basically tell Blender to only render the front face of the object. And now our transparency should fully work as we expect. But to finish this thought, we were talking about how we could potentially show our logo truly transparent within Blender. Transparent where the background is transparent but the logo isn't. And of course this should be pretty simple now, right? Because just like everything else, currently this alpha is being applied to the entire object as a whole. But like everything else, we can go ahead and pipe our image into that, and now instead it will go pixel by pixel and check to see if the alpha should be set to true or not. So if I pass our alpha from our texture into this alpha, you can see that it's actually showing our logo with 100% alpha, so fully opaque when it gets to the pixels in our image that had an alpha of 1, just like we talked before, right? If I right click on this guy, I'm in my UV editor. If I go back to image editor, right click on here, at the bottom there you see our alpha is 1. If I go outside, alpha 0. So we're actually using that property to drive our alpha on the principled BSDF. So there is one potential option you can have there. So we're just going to undo that. In our case, we don't want to do that. We do want to have that leather texture as the background. By the way, I never did this, but if we go to our object properties, back to our UV maps, and one thing I forgot to show is before we just kind of duplicated our old UV map, but you can actually, in addition to scaling them separately, you can actually remap this separate UV map entirely. So I could select all these faces, and I'm going to show you that smart UV project like I did before. I'm making sure that I have the leather one selected. I'm hitting U on my keyboard, and then I'm going to do smart UV project. And now we're in our image editor. Like I said, we need to always make sure we're in the right view. So let's go back to UV editor. You can see compared to the logo one, which remember we had pulled these out separately and expanded this one. Now that I've done this smart UV project, it actually has projected our UVs differently, and we have full control over that. I could have created seams and actually between our two different UV maps had whole entirely different seams and projected them separately. So worth noting that you have the full flexibility of completely two separate UV maps here if you want. So for something like our leather texture, since it is quite uniform, I think this is a situation where it does make more sense just to use our scale map down here. And fun fact, by the way, I don't know if this has ever confused you. It confused me at very first, which is how come when I'm scaling up, my texture actually gets smaller? Doesn't that feel backwards? like everywhere else in Blender, for example, in my transform on the object, right? If I scale this upwards, the object is literally scaling bigger, right? Scale it down, scale smaller. So I was thinking, how come within our shader here and this mapping node, how come scaling this bigger is actually making our texture smaller? Intuitively, it was kind of confusing at first for me. But if you recall in our UV editor here, maybe let's go back to our logo. If I scale this guy, right, I'm scaling him bigger, but the logo is getting smaller. But that's just because the relative size of the logo compared to this UV map is getting smaller. So to me, this is a perfect intuition that explains why this scale getting bigger is in fact making the texture smaller. So this is looking pretty decent, but in my opinion, we're not done yet. Right now, this logo looks very flat on top of our leather patch. And, you know, if you were to literally print on a leather patch, which is not that common, but if you were to do that, this is probably what it would look like, something like this. In reality, though, I think this logo would be burned into the leather patch, right? So that changes a couple things, right? Number one, it should probably almost like inset into this leather patch just a little bit if we can accomplish that somehow, right? When you burn something in, it's actually taking away material. And then on top of that, once we've burned it in, the material underneath is probably not the same amount of reflection, if you know what I mean. Like, so we can see the light kind of reflecting off there. Let me go into my final render view here. So we have our light sources, this point light right here. So if we look at this, the reflectiveness of our logo is identical to the rest of the leather texture. And to me, once someone came in there and burned out this logo, that's probably different. Like, I'm expecting there to be less light reflection on the logo and more on the leather. So that's two things we need to deal with right now. So first, let's talk about the inset. So this is a good time to talk about normals in the shader. So as you can see down here in our principal BSDF shader, we have this input for normals. What is the normal? Well, there's some history here when it comes to graphic design, but it turns out over the years, smart people have found a clever way to essentially mimic depth on an image or on a texture without literally creating more geometry. So what do I actually mean by that? Well, when you're rendering something in 3D, right, bringing it up at the very high level, we have to have geometry, right? Bringing it back to this view here, our solid mode, right? We have a very, very simple geometry here. We just have this top face. We have a whole bunch of these side edge faces, and we have this bottom face. That's it. But if I really wanted to have a lot of detail on this image, you know, look at all these little divots in the leather, right? Without something like normals, we'd have to literally come in here and create a geometry, like very, very tiny geometry for every single little divot in here, so that, you know, when the light comes and reflects off it, it reflects off it in the way that we expect, right? And that's like extremely expensive, right? Computationally and, you know, time-wise too. That's a lot of work to do all that, and your computer is going to struggle. So is there some way that we can actually, you know, affect the way that the light bounces off the surface as if there was geometry there without actually having the geometry there? In a way, like, is there a way to cheat right now so we can, you know, we can get away with that without going crazy with the geometry? So turns out that's where this normal comes in, right? And essentially this normal tells Blender exactly that. When the light hits this texture or the shader in this situation, how should it bounce off of that, right? So, I mean, Blender's now doing more work than if we had no normal at all. Let me take that right off. As you can see, it's a lot flatter looking. Like, yeah, you kind of still get those divots, but they're not actually there anymore, right? This is just actually just a flat texture at this point. The thing that makes it look like they still exist is just, well, it might be the roughness actually. So let me take that guy off. At this point now, it's literally just some fake leather texture popped onto the surface, and that's it. And you can see, like, this feels a lot faker now, right? It feels like that fake wood material you'll see on tables, right? Where it's like not actual wood, it's just like printed wood. It's kind of like that. It looks like a laminated coating on top. So there's these tricks we can do, normals being one of them, to actually tell Blender how to reflect that light. You can see now it's actually changing. And as I rotate the viewport around and we get different lighting scenarios, it's actually bouncing the light off in different ways. And so within the normal map, we have a couple different options. Right now we're using a bump map, and there's essentially two different types of maps you might do here, right? There's bump maps and then there's normal maps. If I come search here, we have normal map. That could have been another one. What's the difference between bump map and normal map? Well, one is simpler than the other. Bump map is just strictly talking about the height, right? So as it goes through every pixel, if the height is 1, then that's representing a higher surface, and if it's 0, it's representing a lower surface, right? right? So as it goes through all the pixels of this leather texture, it will actually pretend this mesh actually has that variation in the height. Normal maps, on the other hand, gives us a little bit more control as opposed to bump maps, which is just based on a grayscale input, so black and white. Normal maps use a full RGB image as the input, where the RGB represent the X, Y, and Z of that normal. So essentially you get way more control. Instead of just an up and down, you can actually represent the angle as well. So normal maps give you more control, but there's often a little bit more work to get that image that you need to represent that normal. And one more thing I want to mention here is, like, I just really want to demonstrate that there is no geometry getting created here, right? If I come at it from this angle, it's not actually adding any geometry. It's just the illusion of it when I view it at, certain angles. It's affecting how the light is reflecting off of the surface. Now, there's one more type of map that I'm not going to go into today, and it's called a displacement map. And the difference between a displacement map and the bump and normal maps is that a displacement map will in fact actually change the geometry. So if I were to pass this texture into a displacement map, it would, if I came down here, you would actually see the variation in geometry. But naturally, this is a much more expensive operation, and it takes a lot more work to get to that point, because in order for it to actually create that geometry, your mesh actually needs to be subdivided enough for it to apply that displacement to, right? So in our case, since I just have a single flat face, my displacement map won't work at all because I only have one face to work with. So I actually have to go into either a modifier, I'd have to come into the mesh itself and subdivide it a whole bunch. In this case, if I actually wanted the detail of this leather texture to this size, I would have to, subdivide this thing into tens of thousands of faces, which in our case right now is not what we want to do. So back to our goal here, how can we make this logo actually look like it's more indented? Well, to do that, we can actually continue to use this idea of a bump map, right? Where the idea being, instead of creating these bumps along the entire texture, what if we actually create a bump for the logo itself, where anywhere that the logo appears, so anywhere where we see this black, will indent down, and then anywhere where we don't see the logo, it'll stay up. How do we do that? Well, if I temporarily disconnect our bump map from our leather texture and I create our own, what we can do is I can demonstrate how this would work with just the logo. So like we did elsewhere, we can just take our alpha channel and pass it into our height of the bump map, and then we can pass the normal into our shader. So it looks like we're getting a little bit of a bump there. In this case, since alpha goes between 0 and 1, where 1, again, is our black surface, we actually want to invert that, because when you burn out a logo within a leather texture, it's not going to go upwards, right? You're burning it into the leather. So to do that, we could either add that invert node in between, or an easier way in this case would just be to get rid of that. And turns out bump has a handy dandy invert checkbox right there. So now we can see that it's actually kind of indenting a bit into the texture. But once again, we're not creating geometry. If we come all the way down here, we start to lose that illusion. But I mean, we're probably not going to be rendering from that angle. And if we really needed that from that angle, then we got to use displacement maps, where we got to just actually add that geometry directly into it, right? But this works for our scenario today. Now, the next question is, how do we actually combine bump maps, right? At the end of the day, we still want our bump map from our leather texture, and now we also want the bump map from our logo. So how do we combine these together? Well, turns out there is no combined bump map operation or combined normal or anything like that. But what we can do is actually just put them in series. And by series, what I mean is I can actually take the bump map from my logo, take its normal, and actually just pop it into the normal of my next bump map, in this case, the leather one, and they'll be applied on top of each other, right? So now I get both my leather texture across the board, and I also get my indent for the logo, which is perfect. Now, with the bump map, you can affect the strength, so I can pull that all the way down, which is don't do anything at all, or I can pull it all up to the max. In my case, I'm going to max it out because I think I want to get as much depth there as I possibly can. And now the next thing is that whole light reflection. And at this point, hopefully you're catching on to, a possible way we can do this, right? We know that we have the ability to basically start with our logo, pass in it's the alpha in the situation, and use that to drive some other value, right? That's what we've been doing kind of for every single node up until now. So is there any way we can do that again? Well, let's start looking into this principled BSDF shader. We have a whole bunch of different options here, right? One of those options, if you play around, is this option called specular. And what we can do is we can just play around. Right now it's at 0.5. We can remember that. So if we pull this all the way down, you see we're kind of getting no light reflection whatsoever. And if we pull this all the way up, we're kind of maxing out that reflection. So the creators of this leather texture thought that 0.5 looked good. I like that too for the leather itself. But like we talked about for the rabbit logo, it'd be nice if we could tone that down a little bit, right? Well, let's go ahead and do that, right? Let's take our alpha channel, let's pass that into our specular, and theoretically that should allow us to change the reflectiveness or the specular depending on whether or not we're on our logo or not, right? So let's pass that and see what happens. Cool. So, okay, not exactly what we were wanting in the end, but the idea is working, right? It's changing the specular depending on whether it's the logo or not. Now, this is inverted. This is backwards, right? So one thing we could do is just add that invert node, pop that in between, and we're reversing it. Still not exactly what we want though, right? Because now basically it's saying when it's not the logo, make it 1. So it's like taking the specular and pumping it all the way up to the top, which we never really wanted. And if it's on the logo, then 0. So it pulls it all the way down, which in my opinion isn't quite what we want. Like, I think I still want a little bit of reflectiveness on the logo, just not quite as much. And I kind of like the 0.5 here. I didn't really want it to max out at 1. So at this point, there's a couple different options we have. My favorite option in this specific scenario is a node called a map range node. If I pop that on here, we can actually now get rid of our invert, and I'll tell you why in a second. Because what map range does is it basically says, okay, so our input range is 0 and 1, right? 0 alpha if we're not on the logo, 1 if we are on the logo. So that's what these two values talk about. From this and then from max, so from 0 to 1. So we can actually keep those the same because that happens to be our current input min and max, 0 and 1. In our case, that's binary. It's always 0 or 1, but and maybe another image, you actually have an alpha that's somewhere in between that. But what this map range allows us to do is we can actually map the from min and max to a new min and max. So basically I can say, okay, 0, which means when I'm not in the logo, I want that to end up being 0.5, right? So the from min 0 can now map to 0.5 the min. Now we're actually getting 0.5 on our leather texture. And then what was the other one? When the alpha is 1, which is a logo, we want the max to be something smaller than that probably, right? We can make it 0, which would take it away completely, or we could probably pump that up just a little bit. But now with this map range, we have that full control. We can basically say for the leather, what do we want it to be? And for the logo, what do we want it to be? And we can control those separately. So this isn't bad. I think I kind of like maybe that 0.1-ish range. You can play around whatever you feel like looks the best. Let me connect my roughness back up again. Put that away earlier, never put it back. That makes it look a little bit nicer. And we didn't do this roughness. This was added for us, but you get the idea at this point, right? Right here, we're applying roughness across the whole. But of course, if we pass it in through a image texture, we can make that vary and get some cool effects. Now, I said there's multiple ways I could have done this map range. The other one would have been this color ramp that is used quite often. When I first tried this out, actually, I was using a color ramp, not a map range. But I just found a map range allows me to be a little bit more precise, right? A color ramp is doing kind of the same thing. You get a little bit more control, right? So instead of using numbers to map from one to the other, you're using colors, where black would be 0 and white would be 1. And you can adjust like the actual distribution of that. So this is where you get more control. But in our case, it's very simple, very straightforward. And I just like the ability to give it these precise numbers instead of a color. So now that we got our roughness back on, I don't know, maybe we want to pull this just a little bit more down. By the way, you can hold shift and that will help you make smaller increments as you're dragging this, because it is a bit sensitive. Maybe somewhere in there is kind of nice. So we're still getting a little bit of that reflection, but it's like it's burned in, right? So it's kind of a little bit rougher, right? We don't have that same specular. Yeah, I'm pretty happy with this. All right, that's it for today, guys. I really hope you learned how image textures really work and how you would use them in the shader editor. I'm sure there's some or maybe even many things you already knew today, but my goal is that you can at least learn one new thing or at least found it interesting along the way. In my next video, we're actually going to take this leather patch with the logo and put it onto a product to create our own custom product video. Super stoked for that. Thanks for watching, guys. I hope you have a great day, and I'll catch you down the next rabbit hole.